All right, so we're going to talk about another complex topic today. So I want you to take your time as you're going through these videos. I want you to don't get intimidated. Take it one piece at a time, one chunk at a time. So the very first thing I want you to do is get out your Pagana book. Here it is. We're going to get out your Pagana book and you're going to look up a CBC. I want you to find a CBC in your Pagana book. Okay, when you go to the CBC in your Pagana lab book, you just basically get a list of all the elements, right? But they have page numbers. So I want you to look at each of these components of a CBC, and I want you to work on understanding them. First of all, red blood cell count, that's just how many red blood cells are in that blood sample, right, per a certain volume. Hemoglobin, let's look at page, am I in the same volume? I'm in the 6th edition, page 251. Okay. Hemoglobin is a measure of the total amount of hemoglobin in a peripheral blood sample. Okay, so I want you to think about the things that can affect the amount of hemoglobin in that blood, in that sample. It could mean there are less red blood cells, fewer red blood cells. It could mean there are too many red blood cells if the hemoglobin's high. It could mean that they have the right number of red blood cells, but they don't have enough hemoglobin in them. So I want you to look at what the test is actually measuring. Okay. Increased levels, what do increased hemoglobin, and decreased levels? What does decreased hemoglobin mean? I want you to do the same thing for hematocrit, which is very closely linked with hemoglobin. Hematocrit also can be an indicator for dehydration. Now, when we look at hemoglobin and hematocrit, they give us an idea of whether or not a patient is anemic. If their hemoglobin is low, H&H is low, they're anemic. So what can help us figure out why that patient is anemic? Well, we want to do some history. Okay, we want to get health history, but also there are some labs that can help give us or point us in the right direction. So we would be anemic, have a low hemoglobin, either because we're losing too much blood, we're breaking down red blood cells, we're not making enough red blood cells, or when we make them, there's not enough hemoglobin in them. Okay, those are the major reasons. So which is it for that individual patient? If you look at red blood cell indices, page 399, they talk about the size of red blood cells and the amount of hemoglobin in red blood cells, and they can give us some idea of why that patient might be anemic. And if you look for each of these, there's an increase and decreased levels with list of what might cause that. So mean corpuscular volume, MCV, is the average size of red blood cells. So red blood cells are typically around the same size. Newborn fetal red blood cells are a little bigger, but they're typically around the same size. So if we don't have enough iron, for example, we might just make fewer, we might put less hemoglobin in them, which we'll get to in a minute. But if we are severely iron deficient, our red blood cells are actually going to be smaller. Okay, so microcytic. There are some other things that can cause those red blood cells to be smaller. Thalassemia, if somebody's anemic because they have a chronic illness. Okay, so you can look at what might cause that to happen. There are things that cause the average red blood cell size to be larger. One of those being if we are out of red blood cells that are mature and we start releasing immature ones called reticulocytes. They are larger and they carry less oxygen. They're less efficient at carrying oxygen. And so an increased MCV might mean that we're releasing too many immature red blood cells. So mean corpuscular volume is about the size of the red blood cells. Mean corpuscular hemoglobin is the hemoglobin, the average amount of hemoglobin per red blood cell. So we would expect that to be low if we have iron deficiency anemia, for example. MCHC is very closely linked to MCH, so we look at those together usually. The other thing I want to look at is red blood cell distribution width. So typically there's a relatively small range of sizes. We talked about the average size. Now we're talking about the distribution. So if the average size is normal, but we've got some fragments or some tiny cells and some big cells, we have a wider red blood cell distribution width, okay? We can have an increased RDW whether or not the MCH is normal. MCH is the MCV, sorry, MCV is the average size. RDW is separate from that. It's the range of sizes, okay? So what might cause that? Well, if I'm breaking down all my red blood cells, then some of those fragments of cells may read as tiny cells. And if I have lost enough blood or I've broken down enough red blood cells that now I'm producing immature ones that are bigger, I may have a wider RDW. Does that make sense? Okay. So when you look at hemoglobin and hematocrit, also look at the red blood cell indices. Sometimes you will see a reticulocyte count done, and that's a count of reticulocytes, which are immature red blood cells. I see it the most in sickle cell, but you will see increased reticulocytes whenever a patient has lost so many red blood cells or so much blood or so many cells, one or the other, that they cannot make enough new fully mature ones. Okay, so they're releasing immature ones and they're bigger. What else is in a CBC? We have white blood cells. White blood cells are helpful in determining if the patient has an infection, but also if what type of infection or inflammation might be present. So I want you to look at white blood cells, but I also want you to look at the differential. What do the different types of white blood cells fight? So let's look. White blood cell count and differential. Increased white blood cell count means they're making more white blood cells. That means either they're fighting some kind of infection or their body thinks they are, or there's something causing them to produce extra. Okay, so we may see that with leukemia as well. Okay, decreased white blood cell count means either something is suppressing the bone marrow, preventing it from producing, or maybe they've run out of the ability to make them. They just run out and their bone marrow has failed because of that. Now, when we look at differential, we look at what do those types of white blood cells fight. So neutrophils, okay, if neutrophils are high, it's more likely to be an acute bacterial infection. But there are some other things that cause increased neutrophils. If lymphocytes are high, it's more likely to be a viral infection or a chronic bacterial infection. If monocytes are high, that's more likely to be a viral infection or a chronic inflammation. You'll also see that with TB. Eosinophils are high in parasitic infection and allergic reaction. Patients with a lot of allergies may have elevated eosinophils. Basophils, you may see more of in some specific bone marrow diseases or in leukemia. Okay, so if we look at which one is increased and which ones are decreased, we can get an idea what type of infection that patient has. The other thing I want you to look at is when you look at the differential, you'll often see all of those types of cells, you'll see it repeated twice. One time you'll see the absolute numbers that were in that sample, and another time you see percentages. And the reason we can look at percentages and get an idea of the ratios. of one type of cell to another type of cell. So that can sometimes also give us an idea of what is increased. The last piece of a CBC is platelet count. So platelet count is critical to clotting. All right, we're going to talk about all of these hematologic and immunologic issues. All of them are very closely connected to, or all of them have to do with types of blood cells, with the components of blood. So you need to have a good understanding of a CBC before you really understand this material. Okay, in the next section, we're going to start talking about anemias.